for following. And there will be a bit of heat also. Please look at the previous class notes if you are having any doubts here. Once you're done, send your answer on my WhatsApp. I will give you guys 2 more minutes and send me whatever you have done. Okay. 2 minutes are over. Please send me whatever you have done. See, I've got from Parker and Khatun. Yes. Parker, very good. Yes, Khatun, very good. Mariam Khatun. Now, what about others? Hafsa, Alia, has done it. Yes, Hafsa, very good. Okay, Aisha. Yes, Aisha, very good. Okay, so Hafsa, Aisha, and everyone, you are getting a hang of it, right, Hafsa? How to do these?
Yes, sir.
Okay, fine, very good. So in this first question, what we need to do, we need to first of all identify the alpha carbon. So this is my alpha carbon. Then I need to identify the beta carbon. So this is a beta, this is also a beta. Now both the betas are same because they're having three hydrogens. So I can attach the, I can remove the OH and remove hydrogen from one of the beta carbons, right? So both the betas are same. I can remove from any one of them and H2 will be removed. No need to write H2 for sure. When they are asking major product, only this much is fine. Even if they are asking write the products, then you are just going to write this propene molecule. And next we look at alpha here. This is alpha. Then we look at beta. So this is beta. And this is also beta. Now let us look at the degrees of beta. So this is having how many hydrogens? 3 hydrogens. And this is having 2 hydrogens. So we have to make a double bond with lesser number of that carbon which has lesser number of hydrogen atom, right? And that is why we'll make from alpha, and this is beta 1, let us suppose, and this is beta 2. So I will make with beta 2. In this case, the third case, we have this is alpha, and both the beta carbons, they are same. That is why I can remove the OH and make double bond with any one of the beta carbon like this. Okay. All of you done? Yes or no? Please tell me.
Yes,
Alia, you got this?
yes, sir. I got the answers.
Okay, fine. You have the phone today or no?
Yes, sir, I do.
Okay, fine. Now, wait a second. What we have already see, we did Lucas reagent and all, no? Acidic dehydration, right? Lucas reagent, Lucas reagent is also done. I think then we need to do oxidation of alcohols. So this is what number? Fourth, fifth one. Right? Oxidation of alcohols. रेट वगैरह सब कुछ डिस्कस कर दिया था ना हमने 3 डिग्री 2 डिग्री 1 डिग्री हाँ ठीक है चलिए please write oxidation of alcohol. Now, in this you will write with me, the oxidation of alcohol involves the oxidation of alcohols involves cleavage of CH bond and OH bond. Cleavage of CH bond and OH bond and formation of C double bond O and formation of C double bond O. Now please see, we have R or rather I should say, we have a carbon atom first of all. This carbon will be having 3 bonds. Now, one of the bonds should be with hydrogen. Okay, should be with hydrogen, and then OH. So from here we have hydrogen, and here also we have hydrogen, right? So both the hydrogen is removed. Removal of hydrogen is oxidation, right? Removal of hydrogen is oxidation, and we will use an oxidizing agent for this particular reaction. There will be some group attached here, there will be some group attached here. Now, we don't want to worry about that. Now, some groups are attached top and bottom. Those group will be as it is. The hydrogen from the carbon will be removed, and the hydrogen from OH will be also removed, and you will get C double bond. This is as simple as that. Now, if you want to see what is happening here, so CH and OH, both of these are breaking, and C double bond O is forming. Okay, now right next. This is AKA dehydrogenation. This is also known as dehydrogenation. Okay, right, next point. Because hydrogens are being removed, dehydrogenation. The formation of product depends on the type of alcohol. Depends on the type of alcohol. That is, whether we are using 1 degree or 2 degree or 3 degree alcohol, and the oxidizing agent used. And the oxidizing agent used. Is everyone done? Yes or no? Please tell me. All of you done?
Yes, sir.
Okay. Now, oxidizing agents can be classified into 2 types. Whatever we are going to use, that can be classified into 2 types. Oxidizing agent. One will be strong and the other will be mild. Okay. Strong oxidizing agent and weak oxidizing agent. So, what are strong oxidizing agent? Please write number 1. Aqueous or alcoholic. Okay, aqueous or alcoholic or acidic KMNO4. है ना? So आप पानी के साथ यूज कर लीजिए पोटेशियम परमैंगनेट. You can also use it with acid or you can use it in alcoholic conditions. All of those are going to behave as strong oxidizing agent. Right, the second one. Acidic K2Cr2O7 or Na2Cr2O7. Potassium dichromate and sodium dichromate. Right, the third one. Nitric acid HNO3 Also a strong oxidizing agent. Right, the fourth one, chromic acid. H2CrO4. Okay. So all of these are what? Strong oxidizing agent. Then in the weak oxidizing agent, right, number one, Collins reagent. The formula for this is CrO3 dot C2, or rather 2C2H5N. The second one is known as PCC, pyridinium chlorochromate. Okay, is right. PCC or pyridinium chlorochromate. The formula for this is CrO3 dot C5H5. Oh, wait a second. This is not C2H5. I इसको C5H5 कर दीजिए. This is C5H5. Okay, not C2H5. CrO3 C5H5 N dot HCl. But what you are going to remember, you are going to remember PCC. Okay, that is enough for you. And the third one, PDC. The full name for PDC is pyridinium dichromate. Pyridinium dichromate. Also write the formula. Formula is C5H5NH2. C5H5NH2. This will be 2 hydrogens, so 2 positive. Dot Cr2O7. 2 negative, and these are balancing each other out. Again, in PDC, pyridinium dichromate, you don't have to remember the formula for this and all. You just need to remember PDC. That this is weak oxidizing agent. All of you done? Yes or no? Please tell me.
Yes, sir.
Okay. So we have seen oxidizing agent, and now we are going to see the different types of alcohol: 1 degree, 2 degree, and 3 degree. So first of all, right, number one. Oxidation of primary alcohols. You're right. One degree alcohols are easily oxidized to aldehyde and further to carboxylic acid in the presence of strong oxidizing agent. In the presence of strong oxidizing agent. Next point. Number of carbon atoms remain same. And throughout the process, that means from alcohol to aldehyde to carboxylic acid, the number of carbon atoms will remain the same. So important point while writing the products is going to be useful. Right, the next point, to obtain aldehyde. That means if you want to stop the reaction at aldehyde and you don't want to further oxidize it to carboxylic acid, then to obtain aldehyde, weak oxidizing agent are used. Okay, so for example, if I have R CH2OH, and I is using strong oxidizing agent, then I will get R. This CH2OH will convert to C double bond O, and here also OH, carboxylic acid, है ना? क्या हो जाएगा ये? Or you can write R COOH. ठीक है? When it is what? When it is strong oxidizing agent. And if I have the same molecule, RCH2H, 1 degree alcohol, and in this case, I'm using weak oxidizing agent, then the reaction will stop at aldehyde. That means it will become R C double bond O, and here you will have hydrogen. Okay? Or you can write it as RCHO. All of you got this? Yes or no? Please tell me. All of you understood this? Alia, Aisha, Hafsa, Mariam, Parker, and Mariam Khatoon.
Yes, sir.
You will see primary alcohol, and then you will see whether it is weak oxidizing or strong oxidizing. If it is strong, carboxylic acid. If it is weak, then aldehyde. Done. All of you wrote this down. No? Check. Let us write some questions. Tell me, guys, in the chat, aldehyde or acid, aldehyde or carboxylic acid in the chat, please. What will be formed? This is 1 degree, as you can see. OH is having only 1 carbon atom like this. Alpha carbon only has 1 beta carbon. Tell me in the chat, you will get aldehyde or an acid when we are using PCC. Yes, Alia correct, Mariam Parker correct, Aisha correct, very good. Hafsa and Mariam Khatoon, please answer. Hafsa and Mariam Khatoon. Yes, Hafsa correct. Yes, ma'am. Very good. And please remember the number of carbon atoms will be same. देखिए. Most of the people they write CHO like this. Now tell me how many of you thought about this? Raise your hand that this will be the product. Raise your hand. How many of you thought that this will be the product? In the chat, no one. What is the problem in this then? Tell me. Mariam Khatoon, आप बताएं पहले. Mariam Khatoon, tell me what is the problem in this structure? Is this the right product or wrong product? Yes, Mariam Khatoon. Tell me, like, turn your mind. Is it this one is right structure? Product सही है गलत है? What do you think? Sorry? It is? I can't hear you at all. It is what? Correct or wrong? Tell me in the chat. Parker, tell me. Correct or wrong? Parker?
Wrong.
Why it is wrong?
Because and see it's
Why it is wrong?
because the number of carbon atoms are increased.
It's very good. Hafsa, understood this one? Yes, please tell me that this will not be the correct structure, right? The correct structure will be what? You will write 4 carbon atoms here, right? 1, 2, 3, 4. And this 4th carbon will be CH. Hafsa, understood this? Yes or no? Please tell me.
Yes, sir.
Okay, write some more questions. Okay. And 2 questions, send your answer on my WhatsApp. Send your answers. Yes, Aisha, very good, correct. Okay. Parker, correct, very good. Hafsa, yes, Hafsa, very good, correct. It's good, Hafsa, you're doing very good. I'm really glad. I hope you're not having problem in the classes. Like, I hope I don't speak too much Hindi. Right, Hafsa? Or do I?
No, sir.
Okay. Just remind me, okay, Hafsa? That, sir, ज़्यादा Hindi. I mean, you will say, sir, too much Hindi. Okay.
Yes. Okay, sir.
Fine. So, Khatun, got the answer? Khatun and Alia got the answers?
Sir, I got the second one, but the third one, I'm having some doubt, so I don't know.
You're having difficulty in the third one.
Yes, sir. Like,
What is the difficulty? Tell me.
so the OH, right? So it will be converted to COH, but I think I might have reduced one COH or maybe added one. I don't know. Like, can you just show me a
Send it.
substitute?
No, send it. No, you send it. Send it to me. I will. No, that's fine. What happened? Number of carbon atoms are same, na?
Oh, so it's correct now?
It's correct only.
Okay, okay.
Khatun, what happened? Waiting for you. Mariam Khatun.
Yes, sir.
Sending.
Sir,
You're stuck in the second one? Okay, fine, no problem. So, first of all, identify this is 1 degree carbon, yes or no, Mariam Khatun?
Yes, sir.
Okay. And what is this? Strong or weak? KMNO4. Strong. So, CH2OH will get converted to what we will make? Tell me.
Double bond OH.
Yeah, C double bond O and OH. Right?
Yes, sir.
Okay. And same thing for here. This is also 1 degree.
Yes, sir. This is B.
So here you can directly write COOH. Hai na?
Yes, sir. Yes, sir.
All of you done? Yes or no? Please tell me. Done? Okay, so we have seen primary alcohol, right? 2. Oxidation of secondary alcohols. Okay. And right. 2-degree alcohols can be easily oxidized to ketones. Can be easily oxidized to ketones using CrO3 or any other mild or weak, mild and weak are same, mild oxidizing agent. So we have got one new reagent that is only used for ketones, CrO3, and it is going to, it is used for 2-degree alcohols to get ketones. Okay. So 2-degree alcohols can be easily oxidized to ketones using CrO3 or any other mild oxidizing agent. If you want to further oxidize it, please write for further oxidation. For further oxidation, drastic condition is required. What is the meaning of drastic condition? It means strong oxidizing agent plus high temperature. All of you got this? Yes or no? Please tell me. Got this? Yes or no?
Yes, sir.
Both the parts, right? First part, let us see the reaction. I have carbon. Let me write some examples. I have something like this. This is a 2-degree alcohol, and I'm using CrO3. So what will happen? The number of carbon atoms will be same as it is. Same thing. Just OH will become double bond. Everything same. Just the OH will become double bond O. Now, if we are using a very strong oxidizing agent, so let us suppose I have this 2-degree alcohol, and I use strong oxidizing agent, and this gives me first of all ketones, and then when I use again a strong oxidizing agent in the presence of heat, then what will happen? The bond will rupture like this. Okay, so the bond will break. Carbon-carbon bond will break because of heat. Carbon-carbon bond will break because of heat, and you will get 2-carboxylic acid. Okay, so if I break like this, so here I'm getting how many carbons? 1 carbon and 2 carbons. So there will be a carboxylic acid of 2 carbon atoms like this. And here also I have 2 carbon atoms. So I will get another carboxylic acid of 2 carbon atoms. Okay, so CC bond breaks when we use what? When we use strong oxidizing agent and carboxylic acid is formed. And what has formed? Carboxylic acid. If you see here, the number of carbon atoms are same, right? But if you see here, the number of carbon atoms are decreased. So you will write another point. When weak oxidizing agent is used with 2-degree alcohols, it gives ketone with same number of carbon atoms. Oxidation of 2-degree alcohols in drastic condition. Drastic condition we have already seen, said that of strong oxidizing agent and heat. In drastic condition, leads to cleavage of CC bond, forming carboxylic acids with less number of carbon atoms. Okay. Now, most of you must be having a question, sir, why did not it break from here or here, right? So you don't have to worry about it, okay? It will break from here also, it will break from there also, it will break from everywhere. So we'll get multiple products, okay? Carboxylic acid with less number of carbon atoms, because you will get multiple products here, and that is why this reaction is not very important. They are not never going to ask this reaction. What you have to remember is just that if they ask you like this, what happens when oxidation of 2-degree alcohol is done in drastic condition, then you write CC bond breaks and carboxylic acid is formed. No need to write specify the exact number of carbon atom and the exact product. They will never ask you and they will never give you to write the exact products. But this is important because here it is very easy and they can easily ask you if you are reacting this, then what is the product going to be? Write this down. Let me know once you're done. All of you done? Yes or no? Please tell me. Done? Write some questions. Write products for the following. Send the answer on my WhatsApp. Okay, Mariam Khatun has sent. There is something that you missed in the third structure. See, Mariam Khatun. Third structure. Yes, Parker, everything is correct. Very good. Double. Why that? Tell me, Mariam Khatun. Again, Aisha, you missed something in the third structure. Aisha, you missed something in the third structure. Okay. What about others? Hafsa, please send the answer. Hafsa, please send the answer. Who has not sent? Aisha has sent. Parker and Khatun has sent. Aisha, sorry. Hafsa and Alia, please send the answers. Hafsa, what happened? Hafsa, are you stuck? Hafsa is not here. What
Sir,
about
it's
Alia?
loading. I'm sending you.
It's loading. Okay. Alia, what about you? Alia, what about you? Someone has sent.
So
Yeah. I'm seeing. It is. Oh, my internet is not working. Let's see the laptop. Yeah, third one is also fine. Very good. Okay. See here, guys. See in the first structure, this carbon atom, this alcohol is what? This is 2 degree. And this is PCC, weak oxidizing agent, right? So what will happen? Double bond O like this, right? Yeah, Hafsa, very good, correct. All everything is correct. Then in the next case also, double bond O. Now when you look at this part, then this is 2 degree and this is 1 degree. And the oxidizing agent is weak oxidizing agent. So 2 degree will get converted to ketone. And the 1 degree will be getting converted to CHO. So Hafsa, you have written like this, that is also fine. So this carbon atom will have 1 hydrogen, so it is again CHO, same thing. Mariam Khatun and Aisha, you guys understood this? Yes or no? Please tell me.
Yes, sir.
Right, next. Third case for tertiary alcohol. So if I look at the structure of tertiary alcohol, we will have carbon atom like this, bonded with OH, and 3 other bonds with alkyl groups. Right. Okay. Now what you see here is that this alpha carbon atom it does not have any hydrogen. And the requirement for this type of reaction was what? The requirement was that carbon should also have hydrogen and oxygen should also have hydrogen. Since carbon does not have hydrogen, it's very difficult to oxidize tertiary alcohols. Okay, because why? Because of the absence of alpha hydrogen. There is no hydrogen on the alpha carbon. So please write, these are difficult to oxidize. You can write 3-degree alcohols are difficult to oxidize as the alpha carbon does not have any hydrogen. Does not have any hydrogen. So how can we, this is difficult. So in order to oxidize them, you need a very strong oxidizing agent and again a very high temperature. So right next. These are oxidized using acidified K2Cr27, acidified K2Cr2O7, or acidified KMnO4 at high temperatures. At high temperature. So what happened as a result? Multiple CC bond breaks and mixture of ketones and carboxylic acid is formed. All of you done? Yes or no, please tell me.
Yes, sir.
Right next. Sixth one is the reaction with hot copper. Okay, reaction with hot copper. Now, this also depends on 1 degree, 2 degree, or 3 degree alcohol. So please write number 1. When we look at primary alcohol, copper and 573 Kelvin, this gives aldehyde with the same number of carbon atoms and you get hydrogen gas. When you have secondary alcohol, copper, 573 Kelvin. Then you will get ketone plus H2. When you have tertiary, alcohol, then in that case you will be getting an alkene. The carbon atoms, and one of them will have a double bond. And here you will get H2O. So 1 degree alcohol, this is aldehyde. 2 degree alcohol, you will get ketone. And 3 degree alcohol, you will get alkene. These two are more important. This one is not very important. We will see these two reactions once again in the method of preparation of aldehyde and ketones in the next, in the next chapter, aldehyde, ketones, and carboxylic acid. All of you done? Yes or no? Please tell me.
Yes, sir.
Yes.
No. Right. Next, chemical properties of phenol. Chemical properties of phenol. So in chemical properties of phenol, first of all, we'll look at simple ones, and then acidic nature of phenol we will discuss in the next class. Okay. So write number 1 reaction. Reaction with zinc dust. Okay, all of these are very important reactions, simple reactions, but these are important. Okay. Reaction with zinc dust. So you take phenol, and this is magic. Phenol plus there will be zinc in the presence of a bit of heat, and the OH atom will be disappearing. So I call this magic. What you got from phenol to benzene? Phenol, this is benzene. Okay. The next one. Oxidation of phenol. OH in the presence of Na2Cr2O7 or any strong oxidizing agent. Okay. Na2Cr2O7, you can use K2Cr2O7 also. In the presence of acids such as H2SO4, then you will get benzoquinone. Structure of benzoquinone is something like this: double bond here, double bond here. Here we have a ketonic group, and here also we'll have a ketonic group. This is known as benzoquinone. Benzoquinone. All of you understood this? Yes or no? Please tell me. These two reactions, easy, right? Yes or no?
Yes,
The
sir.
first one is more important. Okay. The first one is very important. You should remember how to convert phenol to benzene directly. How to convert phenol to benzene? Just add zinc dust. Write the third one. Electrophilic aromatic. Substitution. Electrophilic aromatic substitution. Number 1 point you will write here. Since OH is a plus M group. Okay, Aisha. Please write. Since OH is a plus M group, phenol gives ortho and para products on electrophilic aromatic substitution. One more thing. Since OH is electron donating group, the reactivity of phenol towards electrophilic aromatic substitution is greater than that of benzene. So phenol is more reactive than benzene towards electrophilic aromatic substitution. Now we have bromination, nitration, and then we are going to look at some other reactions of electrophilic aromatic substitution. Okay, main यहाँ पे लेकिन आपके पास bromination and nitration ही है. ठीक है, these are the main ones. Please write. Number 1, A part. Bromination. Okay, so when, please listen here, and then you are going to write it. If you have not written, please write it down. Once you have written it down, write bromination, and then you will leave the pen aside and listen to it very carefully. Okay, I hope everyone is done. Please see here. Don't write anything. Please listen very carefully. When we have phenol and we add Br2, and then we do the reaction in the presence of a non-polar solvent. Non-polar solvent or a non-protic solvent, that means the solvent which is not going to convert phenol into phenoxide ion. Now, if I'm taking a non-polar solvent, what is non-polar solvent? For example, if you have CS2, CCl4, so there is no polarity for them, right? So these are known as non-polar solvent. Non-polar solvent. So if I have non-polar solvent, example आपकी किताब में दिया है, in your textbook in CERT they have given CS2. You can also use CCl4, and you can use any other organic solvent which is not going to dissociate, which is not going to help in the dissociation of OH to H plus. Yeah? So in that case, I get two products. I have OH and Br group in the ortho position, and then similarly I have OH and Br group in the para position. Okay, Br group in the para position. But when I use a polar protic solvent such as water, such as what? Such as water, then something different happens. If I use a polar solvent, such as water, then what happens? I get only one product, but this one phenol, it is tri-substituted. Here we have OH as it is, and Br it is in the ortho position, and the same phenol it is in the para position, and it is also in this ortho position. Okay, so we get two different products. Now here, what are the products are we getting? We are getting O-bromophenol, right? This is what? This is O-bromophenol, and this is P-bromophenol. And what is this? This is phenol with 2, 4, 6 substituted. So this is 2, 4, 6 tribromo. Phenol. Please write this down, then we will write the reason why this happens. This is very important, okay? So Br2 in the presence of CS2CCl4, you will get two products. In the presence of water, you will get only one product, that will be tri-substituted. All of you done, yes or no? Please tell me. Is everyone done? Yes or no? Please tell me.
No, sir.
Okay, please write this down. Let me go answer. Let me know once you're done, guys. Anyone still writing? Anyone still
Yes,
writing?
sir. Done, sir.
So you will write here now. See, phenol, we have seen that phenol is a stronger acid than alcohol. And in the presence of water, alcohol does not act as acid, but phenol does. In the portion acidic behavior of acidic character of alcohol, we have seen that. So what will happen when phenol is added to water? This oxygen atom will dissociate the hydrogen will be dissociated and it will get converted into phenoxide ion. And phenoxide ion will have a negative charge, pure negative charge. Okay, so please write in the presence of H2O, the phenol converts to phenoxide ion. Converts to phenoxide ion, and the negative charge on oxygen activates the ring so much. Activates means increases the electron density. Okay, activates the ring so much that the electron density at ortho and para position becomes very high, and it becomes so high that it forms a tri-substituted product. Therefore, it forms tri-substituted product. So when you have pure negative charge, obviously it will be highly electron donating group. And when you have highly electron donating group, that is going to give the electron density towards what ortho and para position. Done, everyone? Yes or no, please tell me. All of you done?
Yes, sir.
Right, next, nitration. You can write this with me. When we use phenol, when we treat phenol with dilute nitric acid, it leads to the formation of two products, O-nitrophenol and P-nitrophenol. Okay. Also, at this particular point, the temperature should also be low. अब आप लीजिएगा 298 Kelvin. So this is O-nitrophenol. And this is P-nitrophenol. Now please write a point here. O-nitrophenol has intramolecular hydrogen bond and p-nitrophenol as intermolecular hydrogen bond. And that is why what is going to happen? The O-nitrophenol will have lower boiling point than p-nitrophenol. We'll see why all of these things. Therefore, O-nitrophenol has lower boiling point than p-nitrophenol. Now let us see what is intramolecular and intermolecular. First of all, draw the O-nitrophenol. O-nitrophenol has a structure something like this: nitrogen with oxygen atom here, doubly bonded oxygen atom here, right? And you have OH like this. So this oxygen atom will have, please see here, don't write anything, delta negative because it is more electronegative to pull electrons, and this hydrogen will become delta positive. Similarly, this oxygen atom will have lone pair electrons, right? This will have lone pair electrons, and because of lone pair electrons and delta positive here, there will be attraction. Electrons, lone pair electrons will be what? Negatively charged. Hydrogen is positively charged. Now this is hydrogen bond. This is hydrogen bond, and hydrogen bond is formed within one molecule itself. Within one molecule itself. Now let us look at the p-nitrophenol. So for p-nitrophenol, I will write something like this. Let us suppose you have nitrogen here, doubly bonded oxygen atom, singly bonded oxygen atom, the OH is as it is here like this. And for the another p-nitrophenol, you have hydrogen here, oxygen here bonded to the benzene ring. And NO2 here like this. Now again, there will be electron density pulling from oxygen atom, delta negative. This will be delta positive. An oxygen atom with its lone pair electron, it will be able to interact with the positive charge like this. Delta positive charge. Now here we have what? This is the hydrogen bond. Now please understand, the hydrogen bond in the p-nitrophenol structure, it is from one molecule to the other molecule. Then again, this NO2 will be having hydrogen bond with another OH. This OH will be having another hydrogen bond with what? Another NO2 of another molecule. So like this, there we have intermolecular attraction. That means the molecules are attracted towards each other. And one molecules are attracted. Different molecules are attracted with each other. It will be difficult to break them apart. That means the boiling point will be higher for p-nitrophenol. And since there is no such bonding, there is no such attraction in the O-nitrophenol, there is hydrogen bond, but that hydrogen bond is intramolecular, meaning it has no role in attracting the other molecule. Whatever hydrogen bond is happening, that is happening inside one molecule itself. So there will be obviously no force of attraction between two molecules of O-nitrophenol. And that is why if there is no attraction, then we will say that will have lower boiling point, and the p-nitrophenol will have higher boiling point. Alia, Aisha, Hafsa, Mariam, Parker, and Khatun, all of you understood this? Yes or no? Please tell me.
Yes, sir.
So this is O-nitrophenol. This hydrogen bonding is, we say it is intramolecular. I will write it intra here. This is intramolecular. Okay. And this is inter. Okay. Now, what is the use of knowing that this is having lower boiling point, that is having higher boiling point? The use is that if there is a difference of boiling point between two compounds, please listen to me very carefully. If there is a difference in the boiling point of two compounds, those two compounds can be separated by distillation, steam distillation. Okay. So, which is, one more question they can ask, which is more volatile. So, O nitrophenol is having lower boiling point. That is why it will be more volatile. Is right here. Next point, since as a liquid, O nitrophenol is more volatile. More volatile than P nitrophenol. They can be separated by steam distillation.